Okay, so we have now reached the end of this unit. And this is interesting. This is the last lesson, but I'm not teaching you anything new. Because in this lesson, we have to bring together essentially everything we've learned. And just as a recap, what have we learned? Okay, so we had Pythagorean theorem, which remember looked like this. C squared equals A squared plus B squared. That's when you wanted to find the hypotenuse. The other version that we used was B squared equals C squared minus A squared. So when do you use Pythagoras theorem? Remember, you use Pythagoras theorem when you know two sides of a right triangle. So if I gave you this, if you know two sides, if that's 8 and that's 10, you can apply Pythagoras theorem to figure out the third side. Just keep that in mind. Now, I'm not going to give you necessarily a recap of that, but what I'm saying is you can go back on your own. But just remember, Pythagoras theorem can be used when you know two sides of a right triangle and you want a third. The other thing that we learned is, remember, every triangle has 180 degrees. So if I were to say this to you, okay, so this is 90, of course, and that's 50. If you know two of the angles, you can always find the missing one just with simple math. 180, take away 90, take away 50, and that will give you your missing angle right there. What else did we learn? We learned SOHCAHTOA. Now that's, simplistic, but remember we learned the sine ratio, we learned the cosine ratio, and we learned the tan ratio. And within that, remember, we started off, first we used each of these to find missing sides. Then we use SOHCAHTOA to find missing angles. And the part what I'm trying to say to you here is this is all fair game. Because what's about to happen to you now, if I erase this, you're going to be given a triangle, a right triangle, with various missing pieces. And the question is going to say, find everything. Now, this is why this is difficult for me. Because you see, I am not in front of you. And I want to say this. There is no absolute definitive way to go about doing this. In other words, if there were 30 people in a classroom, there are so many ways of going about this to get the right answer. It would make your head spin. But on the other hand, if you know your trigonometry, you can solve for everything on your own. And this is one of those things where I can't teach you where to start and where to finish, but if you're solid with your trigonometry, you can get this done. And it's interesting. So basically in this triangle, what are we trying to find? What's unknown here? They want us to find R, side P, and angle R. And it's interesting. I look here at the solution that's underneath here in the notes. I do it differently than they do it as well. But who's right? Well, neither of us are. That's the point I'm trying to make. So I'm going to pick something arbitrarily. I'm going to try to solve for, I'm going to do side P. So I want side P. Okay. So I'm going to use trigonometry. So here you go. I'm going to label my sides. There's my 90, so we know that's hypotenuse. This is the only angle we know, so we go across there, that's opposite. And then by default, that's adjacent. Okay, so I have to solve now for that missing side. Here's the strategy. I'm going to check that I need to solve that. Now, what other side do you know? Does side A give us any useful information or are adjacent? No, there's no value there. But if you look, H gives us valuable information. It does give us a measurement. Now, this is why you write down SOHCAHTOA. You see, I just put check marks next to O and H. Which ratio uses O and H? Well, that's sine. So sine of the angle is O over H. Let's fill it in now. Do we have our angle value? The answer is yes, it's 56 degrees. We do not have a value for O, so we're going to put X there. Oh, it doesn't matter, question mark. Do we have a value for H? Yes, we do, it's 8.7. This is the step where you multiply the two together. So X is going to equal, oh, pardon me while I figure this out, sine 56 times, close bracket, 8.7. I got about 7.21 centimeters. So I have now successfully solved for P. Great. There are so many ways I can go about this. How can I solve now for R? Well, let me erase this. You might have to save some room there or write somewhere else. I'm now going to solve for angle R. Okay, well, I'm going to start fresh. Or sorry, for side R, I want that. Let's label our sides. Hypotenuse. Opposite. Opposite. And then this is going to be your adjacent. Okay, let's check it off here. So, which side do I want to find? I want to find my adjacent. Now, which side can give you any information to help you? Can this side? No, there's nothing there. You have to use this. So we're using A and H. So that's going to be cosine of the angle is A over H. Cosine, our angle value, is 56. What is our adjacent value? We don't know it, so we'll put X or question mark. Do we have a hypotenuse value? Yes, it's 8.7. We're going to multiply those two together. Cosine 56 times 8.7. It's about 4.86, give or take. Okay, so here's the interesting thing. And I guess I erased the answer, but I have solved for P. I have solved for R. The only other thing that we're missing here would be angle R. Well, how can you solve for angle R? Really, really easily. Well, what's that trick, everybody? Every triangle has 180 degrees. I'm going to take away 90. I'm going to take away 56. What does that give you? 180, take away 90, take away 56. Angle R is 34 degrees. Now, big deal. I showed you how to do one, and I am telling you that I can think of so many different ways to start. We could have used Pythagoras' theorem. We could have used inverse trigonometry. It doesn't matter. The point is if you know what you're doing, you can do this in so many different ways. It's going to be very important to don't get frustrated. Try to keep your work very organized and try to stick with the process. And what I would do maybe is have an answer key next to you so as that you can see if you're on the right track. So what I'm going to do right now is, just to prove my point, I'm actually going to pause this video. I'm going to restart because I'm going to run out of time. And I'm going to solve this very same question a totally different way just to prove my point.